Bismillah ar-Rahman ar-Rahim. This is the 6th lab in our course. In this session, we will cover basic SQL. We will carry on with the same topic that we had in this week lectures as well. In Blackboard, you will find the PDF and the presentation. So I'll provide both of them to you. In the PDF, you will find the same slides that I'll explain in presentation. So I'll prefer to use presentation. It's going to be clearer. Lab outline, so it's going to talk about SQL data definition and data types, specifying constraints in SQL, basic retrieval queries in SQL. Schema and catalog concepts in SQL, we had already covered those before. So when I say schema, I mean the same thing as database, so they can be synonyms. We cover the basic standard SQL syntax. There are variations in existing relational or relation database management systems. SQL schema, let me grab the laser so you can follow me. So SQL schema or SQL database identified by a schema name. So whenever you want to create a new database, you will give it a name, right? And this is something that we already covered before, and includes an authorization identifier as a descriptor for each element. We didn't cover the authorization identifier. So now, while you're creating the database, you will also define or identify who is the owner of that database, who can access it, like an administrator. And there is an example in the next slide. The descriptors for each element, we already saw them in the previous labs, like when you just give some columns names and constraints. So here's the definition of the schema elements: include tables, constraints, views, domains, and other constructs. So each statement in SQL ends with a semicolon. We already know that before. So we had executed a couple of commands before, and we saw these semicolons. Here's an example of how to create a schema or how to create a database. So you can write create a schema and then the name, like here, create a schema company. And you can also write it as create database company. It's optional, so you choose the one you prefer. Authorization, and then you define who is the owner of this database. Like here's the authorization is J. Smith, he's the owner. Catalog, in relational or relation database management system, we can put different schemas in one catalog and we keep them in one environment. So that SQL also has the concept of cluster or of a cluster of catalogs. Specifying a new relation, provide name of table, so you can give the table names, and we already saw that in previous labs. Specify attributes, the types and initial constraints. Can optionally specify schema, like create table, then give it the name of the table by defining first the database. So our database or our schema, it's called company. So here it says company.employee. So the name of the table is employee, that belongs to company database or company schema. Or you can write it in this way as what we already saw in previous labs. So create table, then employee. And then after that, we define the elements. So the columns, the constraints, the relationship, and etc. We will see them in a minute. Here's another thing that we already covered in the lab 4, I believe. So the difference between base tables and virtual relation, or base relations and virtual relations. Base relation or base tables, so we know that tables also mean relations. Relation and its tuples are actually created and stored as a file by the database management system. So whenever we create a table using the previous command here, create table, and then we call it employee, that's called base table or base relation. And we have another thing that we already covered in the lab. If you go to the lab 4, I believe, you will find where when we created views. You remember we create a part of a table, we call it a view, and there is a specific syntax to create a view, and that's going to be saved in the view category inside your server. So that's called virtual relations. when you create a view, we use create view, not create table. And that's going to be called virtual relations or views. Here's an example of a relation database schema that we already saw in the many or in the most lectures that we had previously. So it's the company database. Here's the tables or the relations, and we have also the primary key, foreign keys. We can see them clearly. Here is the state or database state that we have a snap of our database. So we can see the employee is filled with information, department location, because we know that it was multi-valued attributes. So it must be in different table, and that table is connected or has a relation with the employee. Works on, project, dependent. And here's how to create them. We already saw previously how we create a table in lab 3 and lab 2, I believe. Also lab 4, we did the same. So you can attend to those lab and practice them or get the answers that I already provide in Blackboard, and you can use them and apply them. You can also try to test out these commands. So here we have create table employee, we have the attributes, here the primary key, here's the data type, here's the some constraint it's provided for us if it is null or not accepting null. Also another table, create department, we can see in create department, the primary key, the D name, it's unique, but it's not a primary key. Foreign key for MGR SSN to be referenced to the employee SSN. That's the relation, or that's the managed relation, if you remember, relationship between the department and employee. So one employee can or managed one department, and one department is managed by one employee. And you can see here's no specification about the referential integrity where we define on update or on delete. So we said that before, if there is no, like it's not mentioned in the command, so it's by default going to be no action for both on update and on delete. And you can see here's the department location relation or table as well, and other table that you saw in slide number 7. So all of them going to be created in slide number 10 and 11. Slide number 12, attributes, date, or data types and domain in SQL. So we talked already about domains, and we said that all the possible values that can be in a specific attribute based on the data type. So we have a data type that's going to be numeric, and we can have integers. A different type of integer can be there. Integers, if you write it as a fully or int, just like integer, or you just write it as int, is going to be same. It can handle 4 bytes. If you put it as a small integer, it's going to be handled 2 bytes. That's the difference. We have also the floating, you know, that if it is like there's command specific like type of attributes such as GPA, salary, maybe prices, you might need to use float or real or double. Float, I believe, accepting 4 bytes, and real and double accepting 8 bytes. I wrote that down in the comments, so I might share that with you as well. Yeah, float 4 bytes and real and double 8 bytes. Character string data types. So I told you already in the lab, when we attended the lab, the difference between fixed and varying. The var, if like, let's take an example here and let's say it again. Here we have character, just character, and we call this type fixed length. So just imagine if the character, like for example, first name, and then I defined the first name to be 10 character, and I put in the data type like this. I chose to put, let me grab the pencil or the pen. So I chose to use char, and inside the end I put 10. So what's going to be saved? 10 characters. You cannot exceed 10 characters. But what if you put 3 characters? Then there is remaining 7. And because it's fixed, okay, what the compiler will do will add a blank will add 7 blank or 7 spaces to the name. For example, if you put 3 name or a character, a first name with 3 characters might be Ali. Ali is 3 characters, so we still got 7 characters empty. So those are going to be filled with the blanks or spaces, and then it will be saved to the memory. So at the end, 10 characters always will be saved to the memory or to the storage, sorry. It's different from the varying length. If you use var char and then you put 10, and again, rather than info for sure. So rather than saving 10 characters every time, it's going to be depending on the name that you put. For example, if you put Ali again here, then Ali is 3 characters, then 3 characters going to be saved in the storage, not the 10. It's not going to be filled with the blank, but the main important thing is you are not allowed to exceed the 10 characters. You have to have a name or first name with 10 characters, not exceeding that, but it's okay to be less than. So this is the difference between fixed and varying. And there is different ways to use fixed length. So you can, if I just erase all and grab the laser again, so you can use char or char actor. And you have for varying length, you can choose var char or char varying or character varying. All of them are the same. We have a bit string. With a bit string, you can save bits like 0s and 1. You just, for example, if you're interested to save 0s and 1s, you can do that, and you can make the data type rather than integer, you can just make it bit, and you define how many bits you would like to. And again, you have the same thing. You can have it as fixed or you can have it as varying. Boolean, Boolean true, false, or in case you do not put anything, that can be null as well. Data type or date data type. So that's going to be for date, and it's 10 positions. Components are year, so that's 4 for year. You can see it here. Month is going to be 2, and day is going to be 2. That's total of 8, and you have the hyphens that complete the 10. Multiple mapping functions available in relation database management systems to change date formats, so that you can define different types of format for dates. Additional data types, we have timestamp data type. It's a combination of the date and time. We already talked about date, and there is another type, it's called time. And the combination between both of them, if you want to know the specific date and the specific time for something, you can do that. For example, if you are looking for maybe transaction or bank transfer or whatever, money or payment, so you will have the date and time at the same time. So that might be useful for you. Date and time is going to be combined. So plus a minimum of 6 position. So plus a 6 position for decimal fraction of seconds. Optional with time zone qualifier. So you can add also the time zone. For example, Saudi Arabia, we are +3 in time zone. So you can add that as well to the timestamp. It's optional. Interval, it's a way that lets you, let's say, add to the timestamp. Let's read the definition. Specifies a relative value. So you will specify a value, and using that value, you can, or it can be used to increment or decrement an absolute value of date, time, and timestamp. So by using this value, you can increase or decrease the time or the date and or the timestamp. That is the interval. We have date, time, timestamp, interval. All of those are data types, can be cast or converted to string formats for comparison. In case you want to compare between 2 times or 2 dates, so you can convert it to string, and then after converting them to a string or cast them to string, you can do the comparison. Basic constraints, we covered, I believe, a lot of constraints in previous labs. So here are 3 are listed. The first one is key constraint, is a primary key. Value cannot be duplicated, and we know that when you specify something to be a primary key, you cannot duplicate it. And when it is a primary key that implicit or applies, it's going to be not null, and that achieves the entity integrity. Also, we have referential integrity, and we know the example that I always repeat. If you have a teacher that teaches two sections when you delete that teacher, what you will do with the two sections. Are you going to delete them? Are you going to just set them to null? Are you going to just raise an error to the user? What you will do? So are you going to set them to default? That depends on the action that you will do. So must have a value that is already present as a primary key or maybe null. That in case you would just want to define it, it must have a value. For example, for the teacher must be present as a primary key in that table and teacher table, or it could be null. No teacher is teaching that section. Specifying attribute constraints, other restrictions on attribute domains. We have the defaults. We talked about it, so you can give some attribute a default value in case the user didn't fill anything there. The default value is going to be there. Null is not permitted for a particular attribute. So in case you don't want that attribute to be null, you can use not null. Also check, if you remember, we can use a check on a specific attribute to just have a condition. So for example, the department number, it must be an integer and it won't be null, as well as it must be at the D number between or a greater than 0 and less than 21. So it's more than 0. So it's from 1 till 20, basically. A primary key close, we saw that before when we define primary keys. So you will just put primary key and then between parentheses, you can define the primary key. That was one way, and there's another way. We also covered that in some of the lab. One of your colleagues, I cannot remember from which group, but he pointed that out and he told us we can use also primary key in front of the feature. So now we can see it here. So D number, integer, and then primary key. Specify one or more attributes that make up the primary key of a relation. Also unique, we saw it already, so you can make a variable or a column unique. So specify alternate secondary key called candidate keys in the relation model. If you didn't, or like if you haven't ever heard about candidate keys or super keys, you can return to the lecture 2 where we discussed relations and other stuff there. So yeah, that's unique. It's a candidate key, but it's not the primary key. What else? Yeah, that's unique. Foreign keys and close default operation, reject update on a violation. So attach referential triggered action, close. We talked about those in details many times. Optional include set null, cascade, set default, no action. Action taken by the database management for set null or set default is the same for both on delete and on update. Cascade options suitable for relationship relations. Using the key or keyword constraint. We haven't used that one before, so that might be something new for you. We haven't used the constraint key word before in our SQL command. So now let us see it. For example, whenever you want to define a new constraint, what you will do, you will just write the keyword constraint, and then you will give that constraint a name, whatever a name it suits you. For example, if you want to put a constraint for a primary key, you can just put the keyword constraint and then you give it a name, for example, primary underscore the table name. For example, it might be teacher. And then you put the constraint that you would like to. So it consists of a name, a constraint, and useful for later altering. So that can be useful for later altering as well. Here's an example. If I grab a pen, so you can see create table employee, and then it starts defining the columns there. You can see here the default for the department number is going to be 1 in case the user didn't define that. So that's what, that is not what we're looking for. We're looking for constraint, and you can see here, this constraint, it's just for primary key. You can done it without it, like here's that constraint from here to here. It starts in this line there. I don't know why PowerPoint keeps doing that, but it starts from here, and here's the comma. So it ends here. So it's just constraint, then the programmer give it a name. So it's called, or the administrator give it a name. It's called EMPPK. So employee primary key. Okay, that's the name of it. And then it defines the constraint. The constraint, it's primary key SSN. You can put it in one line though, but he just put it in 2 lines. You can even delete it. This is what we did in our previous labs. In case you want to have it in this way, or for sure you have to remember it as well for exams. Other than that, you can use primary key straightforward, or you can just use the constraint as well. Here we can see the on update, on delete, under the foreign keys. What else? Another constraint. Yeah, also they use the constraint on foreign key and primary key. So here's another constraint. It starts from here, from the line that, or from the arrow that I put, and ends here. So that's all going to be one code or one statement that starts from constraint, then give it a name. So the name is employee, and then primary, I believe, primary super foreign key. So that's going to connect the supervisors, I believe. Yeah, it's going to connect, or going to define the relation of supervisor or supervision between employees. And we can see it here as well. So yeah, the same. So every constraint, they will just put it as constraint. They give it a name, and they will just define the constraint or write the constraint. Even the unique. So here for unique, so constraint department TSK or task maybe, and then it give it the unique constraint, and etc. I believe this is going to be the last slide. So additional constraint on individual tuples within a relation are also possible using check. So you can use check, and we used that check before. So for example, here's an example for check. If you see check, the department create date must be less than or equal manager start date. So that's going to check 2 columns inside your relation. And this is regarding the check. So all the commands we already discussed before, it will just going to be more practice for you to understand it fully. Try to do it, try even to run these 3 or these 2 pages on your server, test them out, try to add some elements or rows, and try to test also the referential integrity between your rows, if it is based on what you put it as cascade or on delete or on update. Hopefully it was clear session for you all. See you inshallah in coming labs and lecture. All the best.